Achilles versus the infinite, the paradox that broke Greek minds. The greatest warrior in Greek mythology, undefeated in battle, swift as the wind, Achilles. But in 450 BC, a philosopher proved that Achilles could never win a race. Not against an army, not against the gods, against a turtle. This is the paradox that haunted mathematicians for 2,000 years. And the answer changes everything we know about reality. Achilles, you know the name, the hero of the Trojan War, the warrior whose only weakness was his heel, the man who could not be defeated in combat. In Greek mythology, Achilles was synonymous with speed, with power, with invincibility. But around 450 BC, a philosopher named Zeno of Elea proposed something impossible. He said Achilles races a tortoise. Being a gentleman, he gives the tortoise a head start. Let's say 10 meters. The race begins. Achilles runs toward where the tortoise started. By the time he covers those 10 meters, the tortoise has moved ahead. Maybe 1 meter. No problem. Achilles runs that 1 meter. But in that time, the tortoise has moved again. 0.1 meters. Achilles covers that distance. The tortoise moves 0.01 meters. Again, and again, and again. Every time Achilles reaches where the tortoise was, the tortoise has moved slightly ahead. Therefore, Zeno concluded, Achilles can never catch the tortoise. Logic says he cannot win. Reality says he obviously does. Something is very, very wrong. Zeno's paradox is a trap. A beautiful, elegant trap made of pure logic. Let's break it down. Achilles needs to complete an infinite number of tasks. First, reach where the tortoise started. Second, reach where the tortoise moved to. Third, fourth, fifth. Infinitely many steps. And here's the problem: how do you complete an infinite number of tasks? If there are infinitely many things to do, and each takes some amount of time, then the total time must be infinite. But that can't be right. Because obviously, in reality, Achilles does catch the tortoise. Fast runners do overtake slow ones. Motion is possible. So what's wrong with the logic? The ancient Greeks couldn't figure it out. This paradox, and others like it, haunted them for centuries. Because Zeno wasn't really talking about Achilles and tortoises. He was talking about something far more fundamental: infinity. The ancient Greeks feared infinity. Not feared like being scared of it. Feared like recognizing its power to destroy logic, to break mathematics, to unravel reality itself. Infinity was dangerous, paradoxical, impossible. Zeno's paradox shows why. If space can be divided infinitely, if time can be divided infinitely, then motion becomes impossible. You can never go anywhere, because you'd have to complete infinitely many steps first. But motion clearly exists. We move, things move, the universe works. So either 1 infinity is real, and motion is an illusion, or 2 infinity is an illusion, and space and time cannot be divided forever. The Greeks leaned toward option 2. Maybe, they thought, there's a smallest possible distance, a smallest possible time, atoms of space and time. But that creates its own problems. Because what happens at the edge of an atom of space? What happens between atoms of time? The paradox remained unsolved for 2,000 years. The answer came from an unexpected place. Not from philosophy, not from logic, from mathematics. In the 17th century, mathematicians like Newton and Leibniz developed calculus. And buried in calculus is the solution to Zeno's paradox. Here's the key insight: an infinite number of things can add up to a finite total. Let's return to Achilles. He needs to cover 10 meters, then 1 meter, then 0.1, then 0.01, then 0.001. 10 plus 1 plus 0.1 plus 0.01 plus 0.001. Infinite terms. But the sum? About 11.11 meters. Not infinite, finite. And the time it takes? Also finite. If Achilles runs at 10 meters per second, and the tortoise crawls at 1 meter per second, the math shows Achilles catches up in exactly 1.23 seconds. Infinite steps, finite time. This is called a convergent infinite series. The terms get smaller and smaller, approaching zero, so the total sum approaches a finite limit. Zeno's error was assuming infinite steps require infinite time. They don't, not if the steps get shorter fast enough. But solving the math doesn't solve the philosophy, because the paradox still asks a disturbing question. How do you actually complete infinitely many steps? Calculus tells us the sum converges. It gives us a number. But does Achilles actually perform infinitely many actions? Does he cross infinitely many spatial points? Experience infinitely many moments? Modern physics suggests maybe there is a smallest scale, the Planck length, about 1.6 times 10 to the negative 35 meters. So small it's hard to even imagine. Smaller than an atom is to a human, by a factor of billions of billions. Perhaps space itself is quantized. Perhaps there is a smallest possible distance, a smallest possible time. Perhaps Achilles doesn't actually complete infinitely many steps, because below the Planck scale, space itself becomes different, or perhaps infinity is real, and our brains just can't grasp it. Perhaps Achilles does complete infinitely many tasks in finite time, and that's simply what motion is. The paradox resolved mathematically, but philosophically, it's still alive. Zeno's paradox wasn't really about races. It was about how we understand reality. Can space and time be divided forever? Is infinity real, or just a mathematical abstraction? How do we reconcile logic with experience? These questions birthed calculus, which birthed modern physics, which birthed our entire technological world. Every time you use GPS, you're relying on mathematics that handles infinity. Every computer animation showing smooth motion is calculating convergent series. Every physicist modeling the universe is wrestling with the same questions Zeno asked. The paradox also teaches something subtle about mathematics and reality. Sometimes, logic breaks reality. You can construct a perfect logical argument that leads to an absurd conclusion. And when that happens, the problem isn't reality. It's your logic. You've made an assumption somewhere that's wrong. Zeno assumed infinite steps mean infinite time. That assumption felt obvious, but it was wrong. How many other obvious assumptions are we making right now that are secretly wrong? Here's the beautiful irony. Achilles, the greatest warrior of Greek mythology, had one weakness: his heel. One tiny vulnerable spot that killed him. And Zeno found another weakness. Not in his body, in the very concept of his motion. The invincible warrior, defeated by infinity. But there's a deeper irony too. Zeno didn't create this paradox to prove motion is impossible. He created it to defend his teacher, Parmenides, who believed change itself is an illusion. That reality is one unchanging eternal thing. Zeno thought, I'll prove motion is impossible, which proves my teacher is right. Instead, he created a puzzle that drove mathematicians to develop calculus, which gave us the tools to describe change with perfect precision. Zeno tried to prove change doesn't exist. Instead, he gave us the mathematics of change. The paradox meant to stop progress, created progress. Can Achilles catch the tortoise? Mathematically, yes. The infinite series converges. 1.23 seconds. Physically, yes. Motion exists. Fast things overtake slow things. Philosophically, the question still echoes. Because every time you walk across a room, you complete infinitely many tasks. Every time you move, you divide space and time into smaller and smaller pieces, approaching, but never quite reaching zero. Reality is comfortable with infinity. Our logic struggles with it. But the universe doesn't care about our comfort. Zeno's paradox, created 2,500 years ago, still challenges us today. Not because we can't solve it. We can. But because the solution reveals something strange and beautiful about the fabric of reality. Space can be divided infinitely. Time can be divided infinitely. And yet motion happens. Change happens. Life happens. Infinite steps. Finite time. The warrior catches the tortoise. The arrow hits the target. The universe moves. And somewhere, Zeno is still arguing about it. Welcome to infinity. It's smaller than you think.